And here we go. 1.2 solving multi-step equations. All right, so these are going to be a bit trickier than our last ones because obviously they have multi-steps. So if you have multiple steps, how do you know which one to do first? Right? If you have something like in our first example that says 1.5x plus 15, how am I supposed to know if I'm supposed to divide by 1.5 or subtract 15? Well, what we're going to have to do is essentially order of operations in reverse. So you kind of might know this as a way of remembering order of operations, and we're going to do that in the absolute reversed direction. That way we're undoing things in the order in the order that they would have been done. Alrighty, so let's see what this looks like in action. Example 1, the height in feet of a tree after X years. Okay, so we got a couple pieces of really good information here. I just want to check out the height in feet of a tree, X years, and then we have an equation. After how many years is the tree 24 feet tall? Okay, so we have some pretty good pieces here. I have an equation. Whoa, hey there. An equation 1.5 x plus 15, which is supposed to represent height, the height of the tree. So it says, like, say it's 10 years old. You will put a 10 in here. 10 times 1.5 plus 15, that gives you the height. Okay, so what is it I'm trying to figure out? How many years after the tree, how many years is the tree 24 feet tall? Okay, so it's giving me how high it is, how tall it is. So it's giving me this. So 24 is what goes into the height, and I'm still trying to figure out what would be the years that I would have to put into this equation to have made a 24 happen over there. Okay, so now I have, why did I put a 12? So now I have an equation with multiple steps in it and one variable. So over here, I have some multiplication going on, and I have some addition going on. Now, what do I need to figure out? I need to figure out which one to do first, and so I'm going to go into this idea. And I'm going to think, all right, I have some things that are happening to the variable. The variable is being multiplied by 1.5, and then added to 15. Right? So if I work backwards and do my order of operations backwards and, doing the operations that are going to undo them, I will subtract 15 first. Because I'm going to have to go from the bottom all the way up. Subtract 15. And then I have to do it to the other side in order to keep things balanced. And over here, 24 minus 15, that gives me a 9 equals 1.5x, and then positive 15 and negative 15, 0. Very good. Now I'm going to go even farther up the list. This one's been taken care of. And I'm going to undo the multiplying of 1.5, which means I'm going to divide by 1.5. And divide on this side to keep things balanced up. 1.5 goes into 9 how many times? Oh goodness, it's a decimal going into a whole number. How does that work? Well, 1.5 goes into 3 twice, right? Like 1.5 times 2 is 3. So if 1.5 goes into 3 2 times, how many times does 3 go into 9? 3 goes into 9 3 times. So that must mean that 1.5 can go into 9 2 times 3, 6 times. So 6 equals, and then what's left over here, these things go away, x. Fantastic. Now what this is telling us, if we go back to what our problem was asking, is that after 6 years, the tree will be 24 feet tall. Very good to always go back and make sure that you're understanding what it is you just did and what it is that your work has provided you. In example 2, we're looking at the idea of combining like terms in order to solve an equation. So, when we go about doing this, we need to actually figure out first what are like terms, right? Like terms are terms that have the same variable and the same exponent. So like terms have to have the same variable and exponent. Now let's take a look at a couple of examples of different terms. So let's say I have a term that's like a 3, one that's 4x, one that's 15, x squared, one that is, we'll keep it at that. Let's start with just these three. None of these are like terms, right? The 3 doesn't have any x's, whereas these two do, so they don't have the same variables. The 4x and the 15x squared both have x's, but their x's have different exponents, right? If I don't see an exponent here, it's a 1. So this is x to the first, this is x to the second. They have different exponents, they're not like terms. If I add a new term to this, like 5x, now I see some like terms. Now this one and this one are alike because they both have the same variable x and they have the same exponent of 1. Now if I add another bit to the term, to the list, something like 13. Now I see even more like terms, 3 and 13, because they both don't have any x's. Alrighty, so now that we kind of understand what like terms are, let's see how we can use them in combining them to solve an equation. What we have down here is an equation that has 3 terms on the left, 1 term on the right. On the left side, I can see 2 terms that are alike. I'm going to circle them in a different color. I have an 8x and I have a negative 6x. Okay, realizing the sign of a specific term is going to be very, very, very important. Okay, I don't want you to think of these equations as 8x minus 6x minus 25. This equation combines 8x, negative 6x, and negative 25. Okay, the sign to the left of a term is its sign, and it's going to carry with it regardless of what you do. Okay, when we move equations around, when we rotate pieces, those signs are going to be very important. So let's combine 8x and negative 6x. When I do that, I get 2x. I haven't touched the minus 25 yet, so that's going to stay. And I have negative 35 on this side as well. Now that I've combined all of the x terms on the left, let's combine all the numbers on the right. Okay, now if two things aren't on the same side, it makes it a little bit harder to combine them, but it's not impossible. We're kind of just at this spot where we've dealt with these types of equations before, where now I have to just kind of make it disappear on the left side and reappear on the right side. So to make it disappear on the left side, I need to do the inverse operation. Plus, why did I put a 12? 25. And plus 25 to keep this thing balanced. So the 2x is all that's left over here, because these two, and negative 35 and positive 25 makes negative 10. So now all I have to do is undo the multiplication of 2 attached to the x, and the x will be by itself. Divide by 2, x equals negative 5. Very, 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 very good. Now let's look at our application. We want to use the table to find the number of miles x you need to run on Friday so that the mean number of miles that you run per day is 1.5. Okay, so on Monday you ran 2 miles. On Tuesday you didn't run any. On Wednesday you ran 1.5. On Thursday you didn't run any. On Friday we don't know. So basically when I do the average, or I want to find the mean, you are trying to find all of these numbers added together over the amount of numbers that there are. In this case there are 5 because there's 5 days in this week. So when I add them all together and I divide by 5, what I should end up with, or what I want to end up with, is a mean of 1.5. So all that I've done right here is kind of set up an equation based upon the idea of what average is. You add them all up, you divide by the number there are, and the problem itself is saying that it wants there to be 1.5 of them. Alrighty, so let's just kind of simplify this top here. I know that I have like terms on the top, so let's combine them. I have a 2, a 0, a 1.5, and a 0 that are all like terms on the top. So that makes 3.5 plus x, because I can't combine these because they're not like terms, over 5 equals 1.5. Now I have a multi-step equation here, which is gonna be pretty simple to solve as long as I can do my order of operations correctly. Now it might be a little bit confusing, but this fraction bar is what's called a grouping symbol. Even though you don't see parentheses and I just had to draw them in blue, the fact that the 5 is dividing everything is really a grouping symbol saying that this top, this numerator, is all together and I can't touch it yet until I take care of this 5. So when I go about doing my order of operations backwards, all I see is there is something on the top that's being divided by 5, which means I skip over addition and subtraction, I go right to multiplication division, and I multiply both sides by 5 to get rid of that 5. That happens, this one goes away, and what I'm left with is 3.5 plus x equals 1.5 times 5, 7.5. And then I can now see what was in those parentheses. I can now see, because it's just a one strand of information, that it was 3.5 plus x. So that means that when I go to undo my operations, I'm going to subtract 3.5, and I have to subtract 3.5 over here to keep things balanced, which leaves on the left side just an x, and on the right side 4. So just to remember what it is we were doing this entire time, because we weren't looking just to say x equals 4 and that was the end of it. We were looking to figure out how many miles I need to run on Friday to make my average 1.5 a day. And so on Friday, looks like you're running 4 miles, buddy, which means you probably should have done something on Tuesday or Thursday. That way you didn't have to run so much. But all well. That's the end of it for today. I will see you guys in class. Remember that if you have questions, please write them down in your notes, and we will go over them and we will fix all of the issues. Alrighty, good luck with the assigned work.